Hey guys, welcome back to Business Statistics. This is the second video for section 8.1, and this is where we're going to run a hypothesis test and do it using the p-value approach and not the critical value approach. It's going to kind of run the exact same way except for kind of step 4 and step 6. Okay, so step 4 where we establish our method for rejecting, and then step 6, I guess step 5 too has a little something to do with it. So steps 4, 5, and 6 will be a little bit different, but I think you'll see. What we're doing there. Okay. Alrighty. So let's go ahead and get started on this. So let's read through it. A certain bottling company's most popular products is the 16-ounce or 473 milliliters bottle of sweetened green tea. Data on past productions shows that the contents of the bottles are normally distributed with a standard deviation of 2 milliliters. To assess the state of the bottling process, 20 bottles were randomly selected from the production line, and the sample mean content was 474.54. Conduct a hypothesis test at the 1% significance level using the p-value approach to determine if the actual level is greater than the claimed level of 473. Okay, so basically this is, hey, these bottles are advertised as having a certain amount of liquid in them, okay, a certain amount of green tea in them, and we're saying, well, let's test that. So the status quo is saying, hey, these are supposed to have 473 milliliters in them. And then we're saying, well, we've got this sample of 20 bottles. We're going to test how many milliliters they have in them. And we're going to see if that sample significantly shows that maybe the claim that they have 473 is not correct. Okay? And in instance of this test, it's going to say if the claim is actually greater than 473. Okay? So let's do what we do. Let's go ahead and list what we have here. So 473 is our status quo. So that's our mean. That's our population mean, I should say. Data on past productions shows that the contents of the bottles are normally distributed, so we can assume normality, with a standard deviation of 2 milliliters. Okay? So data on past productions shows that the contents, so not this sample, all right, so past production. So this is still an assumption. So we're kind of assuming about the population that it is 2 milliliters, okay? Then we get onto the sample. So we have a sample size n equal 20 with a sample mean of 474.54. And it's asking us for a significance level of 0.01. Okay, so step 1. Okay, we just write down H naught and HA. All right, we know that it's going to have something to do with mu. That's what's in question. And we know what our status quo mu is. It's 473. Okay, but now we need to know, what are these operators? What are the things that we need to put in there? All right, so we look at this last line, and it says, conduct a hypothesis test at 1% significance level using the p-value approach to determine if the actual level is greater than that which is claimed. All right, so our suspicion is that it is greater than 473. And thus, what do we need to put in for H naught? We don't put in less than, we put in less than or equal to, because it needs to be a complete statement, right? We need to be exhaustive in that, okay? So step 2, what's our significance level? What's our alpha level? 0.01. That's just given to us in the problem. Step 3, what tests do we use? So this is about a mean. So we look at step 1. We know that it's about a mean. And then we have to determine, do we have a sigma or do we have an S? Well, we have a sigma in this case. So this is going to be the same thing as last time. Z-test about a population mean. And then the formula is Z is equal to X bar minus mu over sigma divided by the square root of n. Okay. And then 4, let's do 4 down here. Now this is where things get, I guess, a little bit different with 4. I'm going to go ahead and draw a picture, but we don't need it in terms of like putting the critical value in here. We just need this picture in terms of kind of visualizing the rejection region. All right, so 4, where is our rejection region going to be? Okay, so in the last thing that we looked at, it was equals, not equals, and so it was two-tailed. But remember I said the only time that we're ever going to have two-tailed is if it's equals, not equals. All right, if we have a greater than less than or a less than greater than scenario, it is going to be one-tailed. The way that you determine which side the tail is on is whichever side the operator is pointing in your HA. So we go up here and we look at our HA. It looks like our tail is pointing to the right. So it's pointing, so that's where our tail is. So we have a rejection region here and a fail to reject region here. Okay, and our rejection region is size 0.01. Okay, but now here's where things get a little bit different. So because we're using the p-value approach here, okay, we just know that in order to reject this, we just need to come up with a p-value that is less than 0.01, less than our alpha value. So we'll just say reject if p-value is less than alpha level. And that's equal to 0.01. Okay. So that's that. So establishing the rejection region, a little bit easier, right, with the p-value approach. But we actually pay for that in that we have to then calculate what the p-value is, as opposed to what we did before, where we calculated what our critical value was, or we went and we figured out what our critical value is. We're actually going to have to do that with our p-value now this time. Okay. So step 5 is where we gather our information and we calculate our test statistic. So in this case, we're going to be calculating our test statistic and then obtaining our p-value. So we just use the formula from step 3, and here we go. So we get zcalc is equal to x bar, which is 474.54 minus mu 473 divided by sigma, which is 2, divided by square root of the sample size, which is that. This is going to leave us with a z-value of 3.44. Okay, so it's our z-calc value. So now we have to go and figure out, okay, what is our p-value? Okay, so we'll say z-calc equals 3.44 implies p-value equals what? All right, so now here's how we do this. So we're going to go to our z-table. Okay, so we go to our z-table and we're going to find this z-value of 3.44. So we march down here, 3.44. What is our probability in here? Well, that is 0.9971. Okay, and that stands for the area to the left of that z-value. So what we're really concerned with is what is the area to the right of that. Okay, so we go back here and we say, okay, well, this p-value is equal to 1 minus 0.9971, and that is equal to 0.00029. Okay, and then for step 6, what do? We reject. So we reject because we look at step 4. We reject because p-value is less than alpha value, which is to say that 0.00029 is less than 0.01. Okay, and then step 7, I'm not going to write because it's a lot of wordage and I don't have all the space in the world. Hey, and I'm keeping this video short, so that's good. But so 7, I'll talk through. You guys can write it. And this is just to say that we do have, so we reject, so we are rejecting the null, okay? And this is to say that we do have significant evidence to suggest that the mean of the bottles, the mean of this green tea bottle, is greater than advertised, right? Greater than the 473 milliliters that is advertised in the model. That's that. All right, guys, let me know if you have questions, anything in particular on the p-value or on this problem or anything like that. But yeah, gosh, I'm glad to keep that video short. And I'm going to try to do that with the others while answering the questions. I guess maybe the last video was long because of explaining out the hypothesis testing process. But my voice held up and good on that one, so we're good. So let's keep trudging through. All right, thanks so much, guys. Let me know if you have questions. Bye.